Right. Good day, good day, viewers. Good day, viewers. We are going to look at physics today. We're looking at physics today, and this series is from SS1 to SS3. Looking at physics today, this series is from SS1 to SS3. Mind you, this is Mathematics Made Easy by Prosper Nnodi. Mathematics Made Easy by Prosper Nnodi, and we're looking at physics from SS1 to SS3, solving questions. Alright, we will look at the topic scalars and vectors. Scalars and vectors. Scalars and vectors. First, you must know that scalar quantities are quantities that have size but no direction. That is, they have magnitude but no direction. Now, vector quantities have both magnitude and direction. Take notes. Scalar quantities have magnitude but no direction, and vector quantities have both magnitude and direction. Alright, so scalar quantities are quantities that have only magnitude but no direction. Now, magnitude means size or numerical value. Size or numerical value. Now, vector quantities, on the other hand, have both magnitude and direction. So they actually specify their direction either in the north, south, west, or east, or perhaps northeast, northwest, southeast, southwest, with respect to this cardinal point. So vector quantities always have direction. Okay, that direction is the bearing. We are going to solve problems. We take the first question. First question, they said two forces whose resultant is 100 Newton are perpendicular to each other. If one of them makes an angle of 60 degrees with the resultant, calculate its magnitude. Now, we are given that sine 60 degrees is equals to 0.8660 and cos 60 degrees is 0.500. Okay, now let's solve this problem. Two forces whose resultant is 100 Newton are perpendicular to each other. So that means for them to be perpendicular to each other, these forces will be perpendicular to each other. It means that they are inclined at 90 degrees. These are the two forces. Force 1, then force 2. Force 1 can be called Fy, and force 2 Fx. Perpendicular to each other, 90 degrees. We said the resultant is 100 Newton. Now the resultant of these forces, F, is 100 Newton. Okay. Now they say we should find they calculate its magnitude. If one of them makes an angle of 60 degrees with the resultant. Okay, now let's assume that this force Fx makes an angle of 60 degrees with the resultant. Now that implies if this is 60 degrees, then this angle will be what? 90 minus 60 degrees, which gives us 30 degrees. So that implies that this angle will be 30 degrees. 30 degrees. And whereas we had this force, the resultant force, as what? 100 Newton. Okay. This is the acute angle of 90 degrees. Okay, this angle is 60, then this should be 30 degrees. Okay. Alright, so these are both forces Fx on the horizontal axis and Fy on the vertical axis. They are perpendicular to each other. That means inclined at angle of what? 90 degrees. Acute angle, that's the perpendicular angle there, 90 degrees. Now, they say one of the forces makes an angle of 60 degrees with the resultant. This force makes an angle of 60 degrees with the resultant, 100 Newton. Now, calculate the magnitude of this force Fx. The magnitude of the force Fx. Okay. Okay, let's look for the magnitude. Alright. Now what we simply do, okay, now you can cut out this section. Cutting out this section, you'll be having this. You cut out this section, you have this. This is 60 degrees. And this is 90. This is 100 Newton. 100 Newton. Now, Fx is what we are looking for. Okay, this is what we are looking for. Now, it then implies that this side becomes your what? Opposite side. The side facing this, this side is actually facing this angle is the opposite side. The longest side is the hypotenuse. The hypotenuse. And this side becomes your what? Adjacent. Adjacent side. Adjacent. This is the opposite. This is your hypotenuse. Alright. Now what you simply do now, you solve it straight. Solving this straight, that implies you will have this from trigonometric ratios. There is this thing they call SOCA. Okay. Now, since we need the adjacent side and we have the hypotenuse side, then implies we can make use of CAR. So now we say cos 60 degrees will be adjacent over hypotenuse. That is adjacent to hypotenuse. The adjacent side now is Fx. And the hypotenuse is 100. Okay, so if you cross multiply now, you have, this is it, that cos 60 degrees equals to Fx over what? 100. This is over 1. You cross multiply, this multiplies this. You have Fx equals to this times this. You have 100 cos 60 degrees. Alright, so we are told that cos 60 is 0.5. We are told that cos 60 is 0.5. So this is 100 times 0.5, which is also 100 times 1 over 2. 2 goes in, 1, 2 going through 100 is 50. This is 50 Newton. Alright, 50 Newton. So Fx equals to 50 Newton. 50 Newton. Alright, Fx is 50 Newton. So the magnitude of the force that makes an angle of 60 degrees with the resultant, therefore, magnitude of force that makes an angle of 60 degrees with resultant is what? 50 Newton. Alright. 50 Newton. That is it. The magnitude of the force is 50 Newton. Okay. Now we are going to solve another problem. So the boy, let's take this other problem. We have tackled this one. Obtain the magnitude as what? 50 Newton. Let's take this other problem. Let's take this other problem. Alright. So the boy pulls his toy on a smooth horizontal surface with a rope inclined at 60 degrees to the horizontal. If the effective force pulling the toy along the horizontal surface is 5 Newton. Calculate the tension in the rope. Okay. Alright, let's look at this question. They say the boy pulls his toy on a smooth horizontal surface with a rope inclined at 60 degrees to the horizontal. So if we assume this to be the boy, then this is the rope attached to his toy. Okay, and this is the horizontal level. And we are told the rope was inclined at 60 degrees to the horizontal. This rope inclined at 60 degrees to the horizontal. This is the rope. And this is the toy. This is the boy. Okay. Now they say that if the effective force pulling the toy along the horizontal surface is 5 Newton, this is the effective force. The effective force acting on the rope. The effective force acting on the rope is 5 Newton. The effective force acting on the rope is 5 Newton. Now they say calculate the tension in the rope. The tension in the rope. Actually, you know, they said if the effective force pulling the toy along the horizontal surface is 5 Newton, the tension in the rope, T, is what we are looking for. Why? The effective force pulling the toy on the horizontal axis, that is Tx. Tx is 5 Newton. Now you know that tension is actually a force. So tension, T, is also what? A force. So in essence, I can still call this F. I can call this F and call this TXFX. Okay. So what we simply do now, we will apply our trigonometric ratios here, extracting this out. So extracting this out now, you'll be having this 60 degrees here, Fx, which is 5 Newton, Fx equals 5 Newton, and this force which we are told to find. Okay, of course you know that this should be Fy. This should be Fy, we have no business with that, but this is Fy, okay? Now, this becomes your hypotenuse side facing this 90 degrees, and the side facing the angle of inclination is your opposite side. This is the adjacent. So in essence, we can say that from trig ratios, that what's it called? Cos 60 degrees will be adjacent over the hypotenuse. Okay, so cos 60 degrees is equals to, the adjacent is 5 Newton over, or you can say Fx over what? F, which is the hypotenuse, which will give you 5 Newton divided by what? F, right. Now what then is F? Making F the subject of formula there, we say that F is equals to what? 5 divided by cos 60 degrees. This is 5 over cos 60 is 1 over 2. So F now is equals to 5 divided by 1 over 2, which is 5 times, this 2 goes up and 1 comes down. This is what? Times 2 over 1. And 5 times 2 is what? 10. Alright. So if that be the case, that implies